So when we started the process of developing these presentations, these two were a meeting that I would look forward to every single week, because they came with such energy and enthusiasm, and frankly, probably a lack of sleep that made them a little giggly. And so they would come in and they would make each other laugh, and before we knew it, we were just all laughing, enjoying, and having a wonderful time. But the reality of the situation is that their innovation is amazing, and how they come together creates a really nice partnership for what we can do for our world. And so, without further ado, Avalon Hoek Spaans and Audrey Batzer.
So what do you guys think of this image?
Does anyone notice anything strange?
We've got this man here, and he's trying to stop sea level rise with his own hand.
How many of us have felt like this before?
Trying to tackle global issues single-handedly.
In times like this, where environmental problems seem overwhelming, I like to turn to my mentors. A great mentor told me that the reason there are so many problems in the world is because we turn away from suffering. To change the world, we must run towards adversity with open arms.
Well, we think that maybe the first part of running towards adversity is simply listening.
So we're doing just that, sitting in Biolab one day. But as many of you guys know, one of the problems of being a millennial is that you have a really small attention span. So you try your best to focus during those really long lecture classes. But suddenly, you look around the room, and half the class is asleep. And you're completely lost in the slides. So you're out.
Our class was headed this direction, as our TA Chris was saying all these words about plants, and plants, and plants, and plants do this, and plants can do that, and look at these plants, and look at those plants. He was presenting slide after slide after slide on these organisms. And you know, you get to a certain point where you're pretty much completely lost.
But then I heard him say something, and those particular words began to grow in importance, as one of these plants had the ability to reverse climate change, and in fact, had done so before.
When he said that, Avalon and I looked at each other almost with confusion, and then shock, and then curiosity. To elaborate, we're going to take you guys back. Back in geologic time within the Cenozoic Era, where something monumental occurred.
50 million years ago, the Earth was in a major warming period, and it had been like this since the late Paleocene epoch.
But during the mid-Eocene epoch, and over the span of just 1 million years, which is a mere second in geologic time, a certain event caused the global climate to jumpstart into a complete reversal, starting to shift from a severely warming climate into the modern icehouse world. Carbon levels, which had been as high as 3,500 parts per million, halved within this period. And just to put this in perspective, current carbon levels are at about 400 parts per million. This swap all began because of a single plant, which covered the entire Arctic Ocean at the time.
This plant covered a layer of fresh water, which then discharged into the Arctic Ocean from various high-flowing rivers. When the plant died, it settled down to the benthic oceanic layer, where because of anoxic conditions, it did not decompose.
Rather, this plant, which over its lifetime had sequestered enormous amounts of carbon, was now buried in successive layers in sediment, acting as a huge carbon sink. Today we can look at the fossil record and see layers upon layers of the superorganism buried within the sediment, providing proof for this tremendous event.
Ooh. So what is this superorganism we speak of?
A plant so powerful it's capable of altering the entire global climate.
Now what if we told you that this plant could fit in the palm of your hand?
It's called a Zola.
Now, it's 2016. Why would anyone invest in this fern? Big ideas like this always seem unattainable, until they work.
Nowadays, it seems like the world is just sitting back and waiting for some sort of all-encompassing technological solution to appear. And it's not that technology isn't a solution. It'll certainly be a part of addressing all of these environmental factors. But why have we forgotten about nature when talking about these problems?
Nature isn't an obstacle. It can be a solution. Zola has shifted the climate before, and it's part of the reason we stand here today.
Zola has so many potential modern applications.
Biofertilizer, feed,
Hydroponics,
mosquito control,
biofuel.
water filtration.
But it's not about what it can do.
It's about what it can be. Now this plant is able to double its body weight in just 2 days. So introducing Zola to non-native environments could in fact do more ecological harm than good.
Scientists at Duke University and the University of Utrecht have already been researching the biotechnological possibilities of this superorganism through germination research and gene sequencing.
But they have yet to apply them to real-world solutions.
That's where we come in.
Our idea is a customizable solution to climate change, which harnesses Zola's incredible potential to solve modern-day problems.
Ferns for feed.
Feeding the world while saving the climate.
Our business model is to install sustainable aquaculture systems which rely on Zola for fish feed and nutrient cycling. Our main model is based upon a recirculating system which is greatly facilitated by the addition of Zola. Of course, recirculating systems already exist, but Zola makes these systems multifunctional.
We also have a one-tank system which farmers can use just to raise Zola for the use of feed or biofertilizer.
Our models are flexible according to space availability or simply what the local community depends on.
Which is why our models can be incorporated into so many different kinds of systems.
For example, in rice duck farming systems, which are often seen in countries in Southeast Asia, Zola serves several functions. First, Zola can be directly utilized as feed for both the fish and the ducks, and Zola can be planted alongside the rice as a companion crop, because Zola actually hosts a nitrifying bacteria.
Or Zola can be used in, let's say, a dairy farm in Vermont, where a farmer is not looking to raise fish, but is in need of a better feed and biofertilizer. The farmer can utilize our one-tank system, which can grow feed for its cows, or biofertilizer for the grazing fields. Runoff from dairy farms is actually considered a pollutant, but Zola can harness these excess nutrients from the pollution and use it for its own growth, therefore lowering the farm's environmental impact. Our business model is all about adaptability to local conditions and the needs of the farmers. But why use aquaculture? To start off, Zola is an aquatic fern and only needs 3 centimeters of water to grow in. Because Zola can be grown in closed systems like aquaculture tanks, industrial waste like CO2 and heat can be mitigated effectively. Zola can also grow in marginal lands like urban environments, allowing for its application on a global scale. Lastly, because Zola is an aquatic fern, it doesn't compete with arable cropping systems like other feed crops do. Other feed crops, like soybeans, use massive amounts of land and water resources and can be extremely unsustainable. Zola, however, is able to fulfill that role, acting as a great protein source while requiring significantly less water and land resources to produce. As you can see, Zola's protein content per dry weight is much higher than some of the other current feed sources, like sorghum or cowpea. Zola can also be used as a biofertilizer, which can provide a great alternative to synthetic fertilizers, which can be costly to both the environment if not managed properly. The use of Zola as a biofertilizer is actually not a new practice. In fact, it's a common practice in rural areas of the eastern world. Here you can see Zola is being used as a fertilizer in a rice paddy field. However, we in the Western world have yet to utilize this effective biofertilizer on a mass scale. Instead, American farmers typically rely on the mining of phosphates and the use of various other synthetics to provide fertilizers which can be detrimental to local environments when used excessively. Zola relieves farmers of this costly dependence, thus creating a self-sufficient system for themselves. We want to work with the University of Florida and other organizations to help bring these self-sufficient systems to the Western world. With their help, we can begin implementing these sustainable models. Farmers feed the world, but right now they don't have a seat at the table for climate change. Ferns for feed is their seat at the table. The average person struggles to recognize the effects of climate change in their everyday lives. But farmers deal with its consequences every day. Their livelihoods depend on the regularity of the climate. But we don't expect farmers to single-handedly solve climate change, but they need to be a part of the solution. These are small farmers in Jacksonville, Florida. On their 7-acre urban farm, they work incredibly hard to provide produce to those who need it the most. Their farm is one of many being affected by the irregularity of growing seasons. With just 2 people working in the fields, it's incredibly hard for them to keep up with the erratic jumps in precipitation and temperature. I personally have been able to see the effects on the land and the farmers firsthand because these farmers are actually my parents. Sorry. I think they deserve a voice in the climate change conversation, don't you?
With Ferns for Feed, we want to work within nature to foster a solution. We don't see nature as something we need to dominate or to conquer or deal with.
We need to start listening to the solutions that exist within our natural environment, and it's time to start acting on them.
There's so much information out there. What will you hear today?
But more importantly, what will you do with that knowledge tomorrow? Thank you.